Hello friends, welcome to all of you. This is Professor Dattu Patel. Last lecture we learned about case 1, case 2, case 3 which is solvable for differential equation p, x and y. This is the last topic for the first order ordinary differential equation, Clairaut equation. An equation of the form of y equal to x dy by dx plus f of dy by dx means we replace dy by dx as a p, then y equal to xp plus f of p, that is our equation number 1, is called Clairaut equations, where p equal to dy by dx and function f is a function of p. Now differentiating equation number 1 with respect to x, and we get here dy by dx equal to here product rule, then p plus x dp by dx plus f dash p dp by dx. Here dy by dx, then we replace as a p, then p equal to p plus x dp by dx plus f dash p dp by dx. P minus p, which is 0, equal to, in this term dp by dx common, then we get x plus f dash p. Now here we can write x plus f dash p equal to 0 or dp by dx equal to 0. The solution dp by dx equal to 0, then dp equal to 0, then apply integration both sides, then we get p equal to c. That is our equation number 2. Now eliminating p from equation 1 and 2 means substitute the values of p in equation 1 and we get y equal to cx plus f of c. That is our equation number 3, which is general solution of equation number 1. Hence, the solution of Clairaut equation is obtained only replacing the p equal to c in equation number 1. Let us start with one example. In Clairaut equation, we just replace p equal to c in given differential equation. Example is y minus px p minus 1 equal to p. First, whatever the differential equation given, which is converting to y equal to cp plus f of p form, then first y minus px equal to p upon p minus 1 to become the subject as a y, then px plus p of p minus 1, which is Clairaut form. Y equal to p of x plus f of p, that is a function of p, which is in form of Clairaut form. Then, according to the equation theory of Clairaut form, we find the general solution obtained from replace the value of P equal to C in form of that equation 1. Then we get general solution is just replace P as a C. Then y equal to Cx plus C upon C minus 1. That is our general solution. To solution of Clairaut equation obtained on replace P by C. Another example. Example number 2, px minus y into py plus x equal to 2p. First, given differential equation is not in Clairaut form. Is not in Clairaut's form. Then we convert in Clairaut form with the help of putting x square equal to capital X and y square equal to capital Y. Then differentiating this sum is 2x dx equal to capital Dx and 2y dy equal to capital dy. Now dy by dx equal to, substitute this value 2y dy upon 2y dx. 2 cancel out, here 2x means capital dy by dx equal to capital P and small dy by dx equal to small p. Then here we put capital P equal to y by x into small p to become the subject as a small p. Then x by y into capital P. Given differential equation can be reduced from, given differential equation can be reduced from means substitute the values of P in given differential equation. Then we get here small p equal to x by y capital P into x minus y, small p equal to capital X by y capital P into y plus x equal to 2 x by y capital P. Here x into x, x square capital P minus y square divided by y. Here y cancel out, x common, then capital P plus 1 equal to 2x by y into P, then x cancel, y cancel, then x square capital P minus y square capital P plus 1 equal to 2p. Now replace x square as a capital X and y square as a capital Y. Then we get xp minus y, this term 2p upon p plus 1. Now to become the subject as a y, it means y equal to xp minus 2p by p plus 1, means y equal to xp, here function of p, which is Clairaut form. That is our equation number 3, which is our Clairaut form, means which is a differential equation in Clairaut form, means we find solution of Clairaut equation is obtained from replace P by C, means in this equation we just replace P by C, means capital Y equal to xc minus 2c upon c plus 1. Now substitute the values of capital Y equal to y square, capital X equal to x square into c minus 2c upon c plus 1, which is our required solution, where c is an arbitrary constant. Another example. Next example is e raised to 4x p minus 1 plus e raised to 2y p square equal to 0. First, whatever the differential equation given in question, that is our equation number 1. This given differential equation is not a Clairaut form. Means the given differential equation is not in Clairaut's form. Then we convert the Clairaut form with the help of putting e raised to 2x equal to capital X and e raised to 2y equal to capital Y. Then 2e raised to 2x dx equal to dx, 2e raised to 2y dy equal to dy. Now dy by dx equal to twice e raised to 2y dy upon twice e raised to 2x into dx. 2 cancel out. Here capital dy by dx equal to capital P and dy by dx equal to small p. Substitutes this value, then we get capital P equal to e raised to 2y upon e raised to 2x into small p. Then P equal to e raised to 2x upon e raised to 2y into capital P. That is our equation number 2. Now substitute the values of P in equation 1. Then we reduce our differential equation. Means the given differential equation can be reduced in form of, means substitute the values of in this equation, then we get e raised to 4x small p means e raised to 2x upon e raised to 2y into capital P minus 1 plus e raised to 2y, p square is e raised to 4x, e raised to 4y into capital P equal to 0. In this differential equation, we replace e raised to 4x as a x square, here x by capital Y, capital P minus y, plus e raised to 2y, which is capital Y, that is capital X square upon capital Y square into P square equal to 0. This y which is cancel out, here y taking LCM, then x square by y, then xp minus y plus x square by y into p square equal to 0. Now in this equation x square by y which is common, then x square by y, then we get xp minus y plus p square equal to 0. Now we get xp minus y plus p square equal to 0. In this equation, we convert in form of Clairaut equation, then to become the y as a subject means y equal to xp plus p square. Here that is a function of p, which is in form of Clairaut equation. Now we find the solution of Clairaut equation is obtained from replacing the P by C, means hence general solution is capital Y equal to xc plus c square. In this equation, we replace capital Y equal to e raised to 2y, capital X equal to e raised to 2x. Substitute these values in this equation and we get e raised to 2y equal to e raised to 2x into c plus c square, where c is an arbitrary constant. If you have any doubts regarding these lectures, then feel free contact me. Thank you so much for listening this video.